So these first three examples all involve identifying what is and is not a function depending on how things are viewed. So in this one here, you have tables of inputs and outputs. They could be x's and y's. They could be other variables as whatever too. But you have table A and you have table B, and you're asked which of these describes the situation. Is table A a function, table B a function, both, or neither? As you look at table A, you have each input mentioned only once. Usually in a table, that would be enough to let you know that it is a function, because if it's mentioned only once, it's only going to be associated with one output. And as you see here, 1's associated with 9, 2 with 10, 3 with 11, 4 with 16. So each input is associated with exactly one output, and that makes it a function. However, when you go over to table B, as you look at the input, you have repeated inputs. Now, repeated inputs do not automatically make it not a function. However, when you look to see what they're paired with, this 2 is paired with 8, this one's paired with 7, they're not equal values. That means you have an input value of 2 that's associated with two different outputs. That makes it not a function. And as a result of that, table A is a function, table B is not, so it's only table A that is the function in this group. Now more of a graphing situation. Here we have a scatter plot that shows height as the current independent variable, weight as the dependent variable. So this graph is an attempt to show weight as a function of height. And that's what the first one is asking you, is weight a function of height? Well, I can see here and here that I have two different heights. Looks like about 51 inches and about 56 inches, where there's two different weights associated as outputs. Because these two heights of input have more than one output associated with it, this would not be a function. Now, as far as is height a function of weight? Now, you don't have to necessarily regraph this thing to do it. You could use this graph, even though right now the graph is an attempt to show weight as a function of height. For height to be a function of weight, that means that every weight value, now seen as an input, would have exactly one height value. And you can see right here that the weight value of 140 is associated with two different height values. It looks like 56 inches and 58 inches. And because of that one instance, height is not a function of weight either. So oftentimes that's going to be the case with scatter plots. And even though we sometimes will come up with functions that fit them, the scatter plot itself is itself not going to be a function of any type. Lastly, if you're just given equations. Now, one way of doing this is to graph, and we do have what's known as the vertical line test. And the vertical line test basically says if you're able to pass a vertical line through the graph, and it only intersects the graph in one place, no matter where you place that vertical line, then what you have is a function. If you find any places where that vertical line is going to intersect the graph in more than one spot, it's not. So you could graph these, but there's ways of telling algebraically as well if whether or not y is defined as a function of x. And so to answer that question here, can the equation be solved for y and produce only one output for each input, or produce only one y value for each x value? And so when you have an equation where it's solved for y, you have y equals x squared minus 3x plus 2, and if you put in various x values, it's only going to produce one y value. As long as the x value of like 1 or 3 or 7 only produces one and only one y value, it would be a function. So this, by the basic definition of this, it's already solved for y, and if I put in a single x value, I will get back a single value. So this is a function. Y is a function of x. This one here, it's not currently solved for y, but I can manipulate this. I could isolate the y by subtracting 2x from both sides. And so now I have y equals negative 2x plus 5. Again, if I substitute a value in for x, I'm going to get exactly one y value. So this is an instance where y is defined as a function of x. Well, let's look at this one here. Y squared equals x minus 5. Currently, it's not solved for y. Y is not isolated. And this is where this tends to come in most often. You see that the y is currently being squared. In order to isolate that y, you invoke the inverse operation, which is a square root. But if you remember back from your Algebra 1 and Algebra 2 days, anytime that you have to put a square root into the equation to isolate the y, you have to put a plus or minus symbol on the non-variable side. And since y is being treated as the variable, since we're solving for it, this would be seen as quote-unquote the non-variable side, even though x is a variable. If I square root the left-hand side, I have to do plus or minus the square root on the right-hand side, and so y would equal plus or minus the square root of x minus 5. It is this plus or minus symbol that is the issue, because if I substitute a value of x in, say 6, 6 minus 5 would be 1, the square root of which is 1, I'd have plus or minus 1. So I'd have an x value of 6 producing two different y values, positive and negative 1. That means that this is not a function. Y equals negative 3. This one here requires a little bit more thought, because here you don't have an x involved in this at all. It means that basically y is independent of x. But even with that, that means that if you were to make a table of this, no matter what the x value would be, y would be negative 3. So no matter what the x value is, you'd only get one y value, negative 3. And it would look like a horizontal line. Horizontal lines pass the vertical line test for functions. No matter what vertical line I would draw through this, it's going to intersect that line in only one place. So this is a function. Whereas x equals 7, well, that's a vertical line. That means that the x value of 7 is independent of y. So no matter what y is, x is going to be 7. So I have basically the x value of 7 being associated with all other y values. So you'd have a vertical line. Now, as far as functions go, vertical lines fail the vertical line test, because obviously if I pass a vertical line through here, it's going to intersect in, well, everywhere. So this is also not a function. So that's the end of this problem as well as this video. If you do have any further questions, please make sure to bring them up in class.